Okay, today we're going to learn two new factoring methods, and they're both actually pretty easy. They're kind of the shortcut methods for a lot of these. First we're going to talk about factoring trinomials, and we actually already talked about this last time. So now we're going to talk about a special kind of trinomial. So we're going to look at trinomials that look like x squared plus bx plus c. So basically it just means that there's no coefficient or number in front of the x squared. It's really just a 1, okay? And if you just have a 1 in front of the x squared, then you can do the shortcut that we're going to go through. So we are going to go through it using an example. So we're going to look at how we would factor x squared plus 5x plus 6. So my first step is to write two sets of parentheses with an x at the beginning of both of them. Okay, we're actually already starting to write our final answer. The next thing to do is we're going to list the factors of c. So in this case, our c is 6. So it's a positive 6. So 1 and 6 would be factors. 1 times 6, 2 times 3, and we could also have -1, -6, and -2, -3. And then we're going to choose the factors of c that add or subtract to give you b. So in this case, since we're dealing with just positive numbers, we're going to be adding them together. And I'm looking for which of these pairs of numbers adds up to 5. And I notice that 2 plus 3 is 5, which is that b. So then, this is the easiest part. I just take these two numbers, the 2 and the 3, and I put them in the parentheses with my x's that I created in step 1. So since it's positive 2 and positive 3, that's going to be our final answer. Just write them in. Okay. Now this shortcut is pretty awesome. You have to be careful though. It only works when the coefficient in front of x squared is equal to 1. So don't overuse this shortcut, but use it whenever you can. Okay. Let's look at a few more examples. So x squared plus 11x plus 30. My c is 30 and my b is 11. So I'm looking for factors of 30, so I can do 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Okay, and I'm looking for which pair of numbers, and I could also do, let's just write these out this time. I could do -1 and -30, -2 and -15, right? I could do all the negative versions of the numbers too. And I want to know which pair of numbers adds up to 11, and I notice that 5 plus 6 is equal to 11. So then the way I factor this expression, I have two sets of parentheses. There's an x plus 5, and there's an x plus 6. Okay? So the two examples we've done so far have had all positive numbers. So let's jump to the next example where we've got all negative numbers and see what that looks like. So notice that I still have the coefficient of x squared is still 1, so I can use my shortcut. My c is -10. It's important to carry your negatives with you. And the b is -3. Okay, so my factors of c, I could do 1 and -10. I could also do -1 and a positive 10, 2 and -5, or a -5 and a 2. Okay, so those are kind of my 4 options here. And I'm looking for which pair of numbers do I add up to get -3? And I notice that if I take, I just realized I wrote the exact same thing twice. This one should be -2 times 5. Okay. So I'm looking for a pair of numbers of this list that add up to -3. And I notice that if I do 2 plus -5, that'll get me -3. So 2 and the -5 are the numbers that I'm going to use here. So I'm going to create my parentheses, and I have an x plus 2, so positive 2, and then an x minus 5. So since the 5 that I chose was negative, then I'm going to be subtracting 5 down here in my final answer. Okay. Now let's look at C. So in A we had all positive numbers, B we had 2 negative numbers, and in C we have a mixture of positives and negatives. So let's take a look at what that would be. So my C is a positive 56, and my B is a -15. So I'm going to list out the factors of C. So I could do 1 times 56. I could do 2 times, let's see if I can do this right, 28. I can do 4 times 14. I can do 7 times 8. Okay? And then I could also do all the negative versions of these numbers. So remember that when I multiply two negatives together, I get a positive. So if I'm trying to get a positive 56, then I could make both numbers in each pair negative, and I would still get a positive 56. Now I'm looking for which factors add up to negative 15. So that actually automatically takes out my entire first set of numbers, because if I add up two positive numbers, I'm never going to get a negative 15. So I have to choose which from my negative side of the numbers is going to add up to negative 15. Well, negative 7 plus negative 8, that gives me negative 15. So the negative 7 and negative 8 are my two numbers, and I'm just going to throw them into the parentheses with my x's. I'm good to go. Okay. So this is one of the most common types of factoring that you're going to see. Let's look at just a couple other examples. I want to start by looking at D, because D actually looks like we can't use our shortcut because the number in front of my first term, that b squared, that number is not 1, right? It's a 2, so I shouldn't be able to use my shortcut. But I actually can in this case, because I can start by factoring out a greatest common factor. I notice that every term in my trinomial is divisible by 2. So I'm just going to divide everything by 2 and factor that out. Okay. So I have 2 times all this stuff. Now I can factor this set of parentheses now using my shortcut. So I'm going to look for factors of 72 and figure out which factors of 72 add up to give me 20. And I would make a list probably. So my next step is to look for factors of 72 that are going to add up to 20. So I'm going to start listing them out over here on the side. Just kind of like my work on the side. I have 1 in 72. I have 2 in 36. I have 3 in 24. Let's see. 4 and 18. There's actually a pretty big list of factors here. The interesting thing about this one, though, is if you list all the factors, none of those factors add up to 20. Okay, which means that I can't factor this one any further. So I would be done. Okay, so the factoring I used here was just GCF factoring, and I didn't even get to use my trinomial factoring. Okay, so the first step you always want to do with these is make sure that you factor out a GCF if you can, and then go ahead and try factoring further. Let's look at an example where we do have to do a GCF and then a trinomial. So let's jump down to I. I'm going to let you guys work through the other ones on your own. If you look at I notice that the leading coefficient, or the number in front of my first term, is 1, which is good. That means I can use my shortcut. But the problem is, this is an h to the 3rd power. And so I can't use the method I've been using because this method only deals with when my biggest exponent is a 2, not a 3. So what I'm going to start by doing here is I'm going to factor out an h, because I notice that every term has an h in it. So I'm going to factor out an h. So it looks like that. Then I'm just going to use my shortcut to factor out the parentheses. And I know that negative 12, one set of numbers that I can multiply to get negative 12 is a negative 4 times 3. Or 4 times negative 3. And I notice that if I do 4 plus negative 3, I end up with that positive 1 that I need. So I'm going to use those numbers. So you don't have to list out every factor of negative 12. You just have to list out enough until you find the ones that work. Okay? So that's how you deal with these ones. We'll see lots more practice with these ones as well. Let's jump to one other shortcut. Factoring differences of squares. This might be the easiest kind of factoring as long as you can identify it, okay? So first of all, let's talk about this difference of squares thing. A polynomial of the form a squared minus b squared is called a difference of squares. Remember that difference in math means subtract, and squares are like numbers that you square. Difference of squares always factor a certain way. So if you ever see something that looks like a squared minus b squared, it's automatically going to factor into a plus b times a minus b. Okay? So once you can identify a difference of squares, you can just plug it into this formula and you are done. Now, a couple cautions. This only works if both numbers are perfect squares. And you're subtracting. Okay, so you have to get that difference, which is subtraction, of squares, which means that both numbers are perfect squares. Another caution is not to forget to check for a GCF first. Okay, so here's the steps. There's really only 2 steps here. It's super nice. You find A and B by taking the square root of the first and second terms, and then you just plug A and B into the formula. So let's take a look at what that might look like. Let's just jump down and do this first example right here. I have x squared minus 25. First of all, I notice that x squared and 25 are both perfect squares, and I'm subtracting, so I can use my difference of squares formula. So I think, okay, what do I square to get this first term? So what squared is equal to x squared? That one's pretty easy. It's just going to be x. And then what squared gives me 25? Well, 5 times 5 is 25. So I have my A and my B, and then I just take those and I plug them into this formula right here. So I do x minus 5 and x plus 5. And then I'm done. That's the whole thing. Okay? It's not bad at all. So let's look at a couple other ones. With B, I have 2 perfect squares that I'm subtracting. So my A is going to be m, and my B is 9. Because m squared is m squared, and 9 squared is 81. Then I just plug those into my formula, and I'm good to go. Okay. Let's look at C. So C looks really tempting because I've got something squared plus something else squared. So this is actually called a sum of squares. Remember, sum means add in math? Okay. A sum of squares you cannot factor. You cannot use the shortcut we learned. The shortcut only works when you're subtracting. So this is going to be a prime polynomial. It means that I can't factor it. So with that one, I would just say, hey, it's prime, and move on. Okay. Now D looks a little bit different than the ones we've been doing because there's a number as your first term and then a variable as your second. That's okay. We're just going to factor it the same way. So my A here is going to be 7, because 7 squared is 49. My B is going to be n. So then I just plug that into my formula. So notice that in this case, since my number came first in my original equation, my numbers came first in my sets of parentheses as well. Okay. I'm going to let you guys go through the next set of examples. I want to jump down to the very last one. It's one of my favorite ones to do, this x to the 4th minus 16. Because it looks super complicated, but we can actually factor this fairly easily. So this is a difference of squares because the 16 is just 4 squared. And, one second. Sorry, wanted to wait for the bell to be done. And then this x squared, this x to the 4th is really just x squared to the 2nd power. So our exponent rules tell us that this x squared squared is the same as x to the 4th. So that means that if I want to factor this using difference of squares, my A is going to be x squared and my B is going to be 4. Okay. So I'm going to go ahead and factor this out then. I get an x squared minus 4 and an x squared plus 4. Okay. Now it's tempting to be like, hey, I'm done. I finished it. I factored using differences of squares. You actually have one more step here. If you look at this first set of parentheses, x squared minus 4, that is also a difference of squares, where A is equal to x and B is equal to 2. So I can factor that first set of parentheses down to x minus 2 and x plus 2. Okay. Remember, the second set of parentheses is a sum of squares, so it's prime. So we can't factor it any further, so it's just going to be part of our final factored form. Okay. And that is going to be the final answer for that one. So just some words of caution, like with this problem, you always want to make sure that you can't do more factoring. Okay, we could do 2 sets of factoring here, 2 different kinds of factoring. So always check to make sure that you have actually completely factored it before you decide you're done with the problem.